All right, guys, it is Monday, October 30th, 2017. This is our period 1 lesson focusing on determining the number of solutions to an equation that has one variable. So there are going to be three different types of equations: equations that have one solution, equations that have no solutions, and equations that have infinitely many solutions or infinite solutions. Now, in the past, you've seen equations that looked like this. We've worked with a lot of them thus far this year. So the whole idea here is we want to get the variable by itself, see if we can figure out what number could we put in for m to make this equation true. So if I want to isolate this variable, I see that I have 6m minus 2 equals m plus 13. I'm going to subtract m from both sides so that I only have a variable on the left side of the equation. When we do that, we get 5m minus 2 equals, these m's go away, and we just have a positive 13 on the right. Remember, when I subtract m from both sides, this negative 2 does not change because this is a constant and this is a variable, so we can't combine these like terms. So we're left with 5m minus 2 equals 13. I'm going to add 2 to both sides. When we do that, we get 5m equals 15, and then our last step, we can divide both sides by 5 to get m equals 3. So in this middle column, our solution, m equals 3. In this case, we got a variable equal to a constant or a number. I can put both of those constant. Now, these are the type of equations that we're used to solving. This is what you did in 6th grade and 7th grade. This is where we get the only possible value that we can put in for m to make this number sentence true is 3. So if we check, we would plug 3 in for m. We would get this side equal to this side. So in this case, we say that it has one solution. And again, the reason is the only value for m that makes this number sentence true, or that makes the equation true, is 3. Now, this piece is going to be really important as we get to the end of the unit. You need to be able to explain why a solution or why an equation would have one solution, no solutions, or infinite number of solutions. So we got one out of the way, one solution. Next, we move on to equation B. We have 4y plus 9 equals 4y minus 7. So again, we have variables on both sides. So to get rid of the variables, I might subtract 4y from both sides. Remember, whatever we do to one side, we need to do to the other. When I do that, I get 9 equals 4y minus 4y would be 0, minus 7 would give me negative 7. So in this case, we subtracted 4y from both sides. It eliminated the variable on the left and right, and I'm left with 9 equals negative 7. Now, this might not make sense because obviously 9 does not equal negative 7. So over here, we can have our solution 9 equals negative 7. We say that this has no solution. In this case, we got a number a, in this case 9, equal to b, in this case negative 7, where a was not equal to b, where a and b were different numbers. And then for our explanation piece, this has no solution because no matter what value you put in for y, this equation will never be true. So this has no solutions because no matter what value is substituted for y, the equation will never be true. When I say the equation will never be true, I mean that this side will be equal to this side. That's what this equal sign means. It means this is the same as this. So just quick recap, we have one solution. This is the one that we're used to, where we get our variable equal to some number. We also found that we have equations that will have no solution, where we get two numbers equal to each other, but those numbers are different. And then you're probably seeing where this is going, but we have one more type of equation. We have 3c plus 2 equals 3c plus 2. Now right away you might notice that we have the same thing on both sides, but just for convenience sake, let's just try and do the same thing. We'll eliminate our variables on both sides. So if I subtract 3c from both sides, these go away. I'm left with a positive 2 equals a positive 2. Now this makes sense. 2 equals 2. We have the same number equal to itself on both sides. Now in this middle box, our solution 2 equals 2, we have a constant a equal to a constant a, where the same number is equal to itself. We say that this has infinitely many solutions. If you want to spell that, I-N-F-I-N-I-T, infinite solutions. So in this case, the explanation is any number can be substituted for c, in the equation, and the equation will be true. So no matter what number you pick for this variable c, when we substitute it in here and we substitute it here, this side of the equation will always be equal to this side of the equation. So again, you prove that by solving and finding that two numbers are equal to each other on both sides, and make sure the numbers are the same. So if we run through this one more time, we have our, when we get a variable equal to a number that has one solution. The next example we saw when we have a constant equal to a different constant that has no solution. And then the very last one we saw, we get one constant equal to itself, the same number on both sides of the equation, has infinitely many solutions or an infinite number of solutions.